Thanks everyone for stopping by. This tutorial is about Docling-Graph. I am Krish. I work at IBM in the data labs team. And um, first things first, you can use that tiny URL to directly go to the GitHub repo if you haven't already. Um, this will take you to the repo I'm going to um, follow along in the VS code. And um, if you haven't, I would start with the setup.md file, which should help you set up for the tutorial. Um, we'll be using for the local LLMs using Olama, and you need to download the model weights. At least in this tutorial, I'll be using Gemma 4, which is around 10 gigabytes, so it will take time if you haven't already done the setup. There is also option to use Quen 3 gigabyte model, which should fairly download fairly fast, but I ran into some snags running that. But the fix should be in the latest version of the tutorial repository. Uh, with that, we can get started. Um, how many of you have heard or used Dockling Python? Okay, that's and for people who don't know, the Dockling project is uh, a an AI document intelligence toolkit that helps you process your PDFs or um, HTML files, any of the documents, and make them AI ready. So that you can use them in your downstream tasks more effectively. And Docling-Graph is an extension of that. It still comes under the Dockling project umbrella. It uses Dockling underneath to process a PDF file and generate a clean markdown file with a reading order preserved with all the tables neatly arranged. And this goes beyond to help you build a knowledge graph for your document, right? Um, in If you have experience or used any kind of traditional RAG pipelines or built RAG pipelines, um, in case of documents like invoices or table heavy documents, simple um, embedding based RAG pipelines won't fare really well because if you just extract the top K chunks, most of them are not very meaningful for the large language model. That is where building a knowledge graph and using that will be pretty helpful. And so Docling graph will help you do exactly that. You can define a pedantic object on what your entity should be, and Docling-Graph will build that graph for you um, when you run the pipeline. If you install Olama, make sure that the version is uh, bigger or more than 0.20. So you can do that by doing Olama version. So that's the minimum version you need to safely download the Java model. Um, and once you download Olama and set it up, you can navigate to this screen settings, and here you can adjust the context length. Uh, it automatically determines context length based on your machine's memory. Um, I, my default was 4K, but to run this tutorial, you need at least 8K context length for your local model. So I set it to 8K. And once you do Olama pull the model ID, that will start pulling the model weight into your machine. And rather than using the GUI to set up context length, you can also use this custom command to set up Gemma 4 on your machine with 8K context length, it will create an 8K context length runner for you. And same similar commands for if you want to use Qwen 2 billion model, which is much smaller. It's a 3 GB size. It's ideal for the you want to download it now. And the second part of the tutorial, I'll use one of the remote LLMs because it's a fairly large document, which my machine won't be able to support that processing on Ulama. So for that, I'll be using OpenAI API key. So if you have any of the providers' API keys, you're welcome to use that. Under the hood, Docling-Graph uses Light LLM. So any model that is supported by Light LLM should be you should be able to use that by giving the right configuration here. I provided the mostly used frontier models, how you can set up the API keys here. You can do that in the .env file. And once you clone the repo, um, you can run uvsync command, which will download all the dependencies for you and create a .env directory, which is the virtual environment that you will be using for the tutorial. And once you have everything, you can run the setup check script to make sure that your setup is all. So here, this will make sure that your Olama model is warmed up, and it will check for all the dependencies, example files are they present or not. If there are any challenges here, that means we need to revisit the setup and make sure the project is set up properly. And wait for a bit if people want to um, uh, download the Gemma model or Pen model, and can take any questions for the setup.
Structure look like, format of the file?
So the output, you mean? Yeah. So it the library generates a network X supported knowledge graph, uh, and also the outputs it outputs a nodes and edges CSV, and also there is a Cipher integration if you want to say export into a Neo4j kind of database, GraphDB. You can do that too, and you will get a JSON structure of the graph. So it's more you can use it in any other platform if you want. Which we can when we run the first notebook, should be able to see that outputs. So in this current setup, I have not configured the remote LLMs yet, and it already pre-warmed the Gemma for me, and it will stay alive for an hour. So now if I do Olama PS, it should show the Gemma model loaded, and it's fully loaded into the local machine's GPU right now. So once I'm here, I'm good to go from the first notebook here. In the notebook section, the quick start will set up the right Python environment, which is not that. Yeah. So the local environment shows up in my VS Code. I'll pick that to run the tutorial, the quick start. Here I have already put some data, which is one sample insurance policy with the sample declarations page. This is the sample file the first notebook will be running. It's a homeowner's insurance policy declaration page with some coverage information, the insurer name, the insurance company details, and also people who are insured here. So a sample document we'll be using. And by the end of this notebook, we'll be able to generate a knowledge graph representing um, the entities in this PDF file. The entities which you want to be extracted um, should be defined as a pydantic object, where here there is insurer, insured, agent. Um, all this will go into an LLM prompt to extract these entities, which will be used to build the knowledge graph. Here, I set the force run to true and the provider is local. Then the notebook will pick the local Olama model to run this graph extraction. And if you don't want to set up the local LLM or the remote, there is a pre-run option. So there is already some existing JSON files that you can run the pre-run script to generate these JSON files, which will simulate the output of if you use a remote or the local LLM to just get the feel of the library. Okay, the provider is set to Llama, the Gemma model running in my local. The source is the declaration. And this part is where we are actually configuring the Docling-Graph pipeline. What Here you're configuring the backend. There are two supported backends. One is VLM pipeline and LLM pipeline. We are using in this example the LLM backend. The inference provider is set to the Olama, and the template is what we pass. That's the pydantic object that you created in the cells above. That's the home policy. And there are other settings. So when you set dump to disk true, it will write the graph JSON, the nodes, and everything into the output folder, where the output directory, you can set it here. So now if I run the extraction, you can look at the Olama logs. I don't have that loaded there, but you can see which endpoints or how long the LLM calls are taking if you have the Olama logs. So first, what it's doing is it's calling the Docling library to convert the document into a Markdown format or a Docling document format, and then it's calling the large language model in my machine um, with the pydantic object as one of the prompts. So that's now once the LLM call is done, I think this will take the longest because once we get response back from the large language model, the graph is built by the Docling-Graph library. Okay, yeah, this because I'm running on my machine, it will take around 120 seconds or a couple of minutes, but I can take any questions in the meantime while um, while this is running.
I was hoping that there wouldn't be a schema to define. But it's like, and it works for specific use cases, but that's the big challenge right, with property graphs.
I mean, yeah, I don't know. Like in that case, how do you even control what the output is going to be? When it's tricky, but in domains like like 10Q or 10K documents, you know exactly what kind of tables are there. This helps you get to that point much faster. But yes, if the schema has to be detected, maybe you can build some layers on top of it. Again, using some kind of large language models again, I think. But
Yeah, that's what the talk yesterday was, the talk on that.
okay, yeah, I missed it. So uh, okay. Now the extraction, the graph extraction is complete here. So, so the results are saved to the data, the output. So you see one dockling output, which is pure run the library, just dockling whatever you receive the output. You see it here, and the Docling-Graph output has all this edges, CSV file, graph, HTML. You want to see a neat HTML representation of it, a JSON, and a report empty, which shows more statistics of how your what your graph has. Mostly all the entities, the nodes, the information is shown here. But yeah, if you run through the notebook, it just helps. It does create the visualizations for you so to understand what it extracted. So you see the home policy number is extracted, the insurance insurer details, the insured details, and all the coverages and deductibles is what it is able to get from the graph. And um, this opens if you run through, opens a interactive chat with Graph Explorer on what it is able to what information it's able to extract. So this at center, that's the uh, homeowner's policy, and actually zoom in here. Oh, oops. And all the blue nodes are the deductible information, and if you click on that, the amounts are saved as node attributes, and there are coverage kind of nodes, and that talk about what kind of coverages the homeowner has, and the insurer, uh, pick the address, the phone number, the name, the company information, and the insured are the people who bought insurance. So um, So this knowledge graph is what you can use for the downstream processing of your tasks. So um, the next part of the notebook queries this graph for some simple questions like list all the coverages or exploring the graph in a little bit more detail. Um, and also, the notebook compares if you want to extract the same information using a regular old school drag versus using a graph. It shows uh, what benefits you get from using a knowledge graph approach. Um, Here you are simply creating chunks of the document and doing a basic vector search. This is a very small document, so we don't need a vector database in this case. It's just using saving all the weights, all the vectors in the memory. And here, what we run through the end of the notebook, what it shows is how the knowledge graphs that we extracted can be effective in answering specific questions about the document. And um, before I move to the second notebook, If there are any questions or about the notebook or the library, feel free to ask. Uh,
I missed the rag part. You said you would show like why the rag is not as good.
yeah, so here this part, right? So if you if you ask questions like list all coverages and the coverage limits from the homeowner, so the chunks, if you send this to uh, say you save all these chunks into a vector DB and pick n number of closest chunks, what you'll get is this pieces of text, which is not very meaningful, right? So even if you put that, send that into an LLM, it will not be able to answer that question for you. So, that is where your traditional embedding based RAG falters because um, there is no way VectorDB can comprehend list all the because it says it's either you should do a text to SQL kind of conversion to do if you have all the data in queries tables, or at this point when that question comes, you would pass the whole document to the large language model, and then it would figure out
Yeah,
the answer.
the rag results will also tell the file name, right? And then the model can do read calls to the entire. It's more tokens, but it can get the.
Yeah, exactly. You can get that. So that's what uh, many solutions do, right? Like at that point, you would pass like you use the vector search only to determine relevant document names, and then pass because with a large context limits, you can just fit the whole context, maybe a large document in that context, right? Definitely you can do that, but graph rag or graph DBs give you an alternative approach. If you don't want to do that or build a knowledge graph, it complements you. It doesn't have to like again, it's not a foolproof, full-fledged solution again. You will need to use a mix of a vector DB and then graph DB to be able to answer the question. So the second notebook, this schema.ipnb, this processes a much bigger document. Here, it's a press release of NVIDIA, um, which has more entities, revenue like metrics. For this, the ideal, at least I rather than using my so local LLM, I would prefer to use the remote LLM because, yeah, total.
Well, and for the graph rag, did you have to embed the graph or like the chunks in the rag? Did you have to embed that, or is it just traverse the graph?
Yeah, so at that point, like, so once that question is more about how do you want to use the generated graph into your RAG kind of pipeline, right? The notebook doesn't go into the depths of that, but ideally, when a question comes into your question answer system, there should be an intent detection or routing where if it is a graph based question, you need to convert text to graph query and then query the graph DB with that query. That is a better approach than embedding or creating embedding for this, like resultant graph nodes. Um, yeah, that's more of an architecture decision.
Sorry, so the graph doesn't have any embedding, right? There's no embeddings for the graph.
No,
It's just the schema and the LLM makes it builds the database final thing that is queried. It's not a vector database, right?
uh, yeah, no,
Yeah.
the Docling-Graph doesn't give you.
Yeah, I just wanted to distinguish the two concepts.
Yeah, it just gives you the pure graph output. Like you can use it in downstream processing, but yeah, it doesn't give you any kind of It doesn't produce any embeddings or anything that you want to use in a vector DB kind of fashion. So I can actually show you that. Yeah, all you get is something like this: edges, the graph HTML if you want to visualize it, but graph JSON with the parent-child relationships and the nodes. So that is the output you get out of this library. And then you have to build the other middleware to use it in the AI pipeline tasks. So for this, the second part of the tutorial, I'll be using a remote LLM because this document cannot be processed in my machine in a practical amount of time. Okay. Okay. So this is the NVIDIA press release document as PDF. This has some tables, some information here about the quarterly earnings of the company. So there are interesting entities like uh, partners, products, the financial metrics that you want to extract, and which can generate some interesting knowledge graphs. This notebooks takes you through how you can define a much complex schema in using Pydantic, and in Pydantic, anything that is like a base model, whatever you define, any entity, that will be one of the nodes, and within, so for example, you have this product, which is a base model, um, and financial metric is a base model. Now you can use them inside another, you can define another business segment class where the product is one of the fields in that. So by doing this, you're essentially defining a more complex graph schema that you want to extract from the document. And same with defining a business partner in this case, where partner is a company that uses NVIDIA technology and deploys their creates a deployment of NVIDIA technologies. So think together in the NVIDIA earnings based Pydantic object, which has all the other uh, all other classes defined within it as fields. Now, once you run the extraction, the provider here I'm using is OpenAI because you can use any of the frontier models to do this, but I'm picking OpenAI here. You don't set the code run to true. It will just the scripts will use existing graph and not go to the extraction. So it is going and hitting the GPT-4o mini, and because this is a bigger document, Docling-Graph, what we chose is a chunking strategy. So it uses creates chunks and tries to generate smaller graphs and then merge them together to build a bigger graph. For a large context model like OpenAI, you don't have to do that, but just this library gives you an ability to define such things like a chunking strategy and how big you want your chunks to be when they go into the LLM for graph extraction. So this process extracts, runs this in a batch fashion and extracts the 30 nodes and 29 edges. and then graph conversion takes place. So it took like 2 minutes to do that with one of the frontier models as a remote LLM. But if you want to do that in your machine with 5 pages, it will take considerably longer time. And if the model supports a structured output, that is, Docling-Graph will handle the structured output. Otherwise, that's the warnings that you're seeing. Either GPT-4o Mini uh, doesn't support structured output, or the light LLM is messing with it, because that's why it's trying to go with the legacy prompt schema more. But end of the day, it'll still extract the graph for you. And one more nice thing about the library is actually I chose a delta extraction methodology here, where it does the extraction contract is delta, where pieces the document and tries to build a graph as subgraphs and merges them together. But in this case, the delta extraction failed. So the quality gate within the library that's built in tries to see quality gate failed, and then it's falling back to direct extraction, which is trying to send the whole document in one piece, and then now it's able to extract uh, nodes and edges in one go. That's also, yeah, I think we can move on here. It's because we already ran the 35 nodes and edges, and it saved all the outputs here in the output directory. I can still run the other cells to visualize and query this graph. So this cell shows a multi-hop query. Like if you want to ask questions like what are all the partners that are working with NVIDIA to use their technology. Um, you can see here a list of companies that are actively deploying, that are mentioned in the report. Um, that's a multi-hop query that is enabled because you're able to extract. So this is much more complex graph. But if I zoom in with NVIDIA at the center and all the metrics, financial metrics, the revenue, gross margin in these nodes, and the partners are colored in red. And the products, the key products that is extracted is colored in blue here. So and um, the third notebook here just takes you how you can take this extracted graph and generate a Neo4j query to persist in a more Neo4j kind of database. I don't have a Neo4j instance here, but if you run through the notebook, it will generate a type of query for you that it can persist in a Neo4j kind of database. I'll pause for any more questions.
Is there a reason you only query with like Python code and not like say like some kind of an AI? Like, like all the examples you showed,
Yeah,
like Python code querying the graph. Right?
yeah, it's a network graph here, right? In the query.
It's cool because we don't burn tokens, but But unlike the RAG approach where you have to embed the query and
Yeah, so I haven't built that in the tutorial, but essentially, in theory, you can simple like text to SQL kind of task. You can use an LLM. That would make it much better. Say, which I haven't built in this tutorial, but it's fair. Um, it's it's not guaranteed that the text to cipher query will work, right? So you need to build um, a loop-like system where first it will check if the query is.
you can do text to Python code, which is the same code that you had in the notebook to do the query. Let the AI generate the Python code to do the query. And then it'll pretty much do what you did, right?
Yeah.
So,
Yeah, yeah, that's true. In this case, we're simply querying because we know the answer. You know the exact query, it will work because you generated the graph. But yeah, in theory, you can use more like a router mechanism, or depending on the question, it should generate a right cipher query, and uh, that's a challenge again. Not all systems can perfectly generate the right query for you. There is another notebook in this, which is the VLM. So I so far only covered the LLM path. There is a the Docling ships with two, I think, neuro abstract models, which act like vision language models. You can use that or to configure your notebook or your scripts to use the VLM path instead of the LLM path. It works well for fully scanned documents with handwritten digits or things like that because the LLM path only does OCR for you. And OCR is um, it can only do well if there are clear tables or cleaner tables, even if they are scanned. But VLM path can also read images and understand charts. It does much better job. Um, but this process is much more taxing on my machine, so I was not able to run the VLM path on on my machine. So I either need a deployed on a GPU or a much powerful machine to do that. I ran into out of memory issues when trying to run this, um, but I wanted to highlight the library does support both pipelines. There is a VLM backend or LLM backend um, to if you want to extract um, better better information from your scanned images. So this works well for billing documents and invoices if they're fully scanned format, not in the PDF form.
Notes. Which vision language models can you use? I know that is Docling-Graph. Is that
So in Docling, if you are using pure Docling, you can it's not Grenade. It supports it by default ships with that 256 million small language model. I think it's called small Docling or something.
small Docling? Yes.
It uses that, but you can configure it to use much powerful VLMs like Quen or anything like that if you want to. Uh, yeah, but um, it is this Docling-Graph is by default using the neuro extract vision model. There are two variants of that new extract. I think new extract 2 billion and 8 billion. But in theory, I can configure it too, but I haven't tried that. So they have a export notebook. Yeah, I think I covered pretty much what I wanted to, but I you are running into any issues trying to run the tutorial or that's somewhere I'm happy to answer. Or any questions about.
Thank you so much for the presentation. I'm going to stop the recording now, and if you have any questions, well, we'll hang around after.